Hello, laser geeks, or maybe not geeks. Hello anyway, and welcome to the channel. In this video, I show you what most people never show, how much time and effort it actually takes to make those perfect welds. What you see at the beginning is the final outcome. If you want to see the full process behind it, stick around. It's a long ride.
Look at this. It's hot. Let's repeat on the other side. Hello everybody. Now I have to hold this, so camera may be shaky a little bit. So when you increase your wobble length, you deliver the same amount of energy to a larger surface area. You reduce the input energy per unit area. Okay. And also you increase a little bit the heat affected zone. Feeding speed, you have to play with it because the factory give you some settings. Let's say, I think in this case, I don't know, like 12, and it's absolutely stupid. I can run it 30, and I'm sitting at 20 right now. So, oh, by the way, this 4mm, forget it, because it's totally different setup. I'm gonna try to show you guys two different type of weldments. I don't have so many coupons left, so this is gonna be very brief. But to get there, what I'm trying to show you, this is I went through all these different tests. I weld the crap out of this stuff. See? Different settings, I was playing with all kind of stuff. Alright. See this pattern in different sizes. This is the same pattern, but it's a slower speed. So when I increase the speed, truthfully it looks like a rope. So anyway, I'm gonna show this. So to get there, what I want to show you, it took probably an hour and a half. Why? I have only 49-50 hours gun time on this machine versus the IPG. I have over 5 years continuous gun time, okay? And I weld every day, and a lot. I don't really count it in hours, I count it in length, and in one of my videos I explained the length. We're talking about a couple of miles. I mean, couple of 100 miles. So anyway, doesn't matter. So I prepped up a little piece over here. Before even I'm gonna hit this, I'm gonna verify I'm doing what I want to do, and it's verified. So it's verified. Let me see. I can go even closer. I hope I'm gonna be able to track right in the center, because I have zero gap whatsoever. It looks like I was able to. Alright. Test piece number 1. Looks like a rope. So I could make it wider, a little bit more elongated, whatever I really want to do. It's very nice. On the other side, we're gonna make it a little bit wider, so it should be a little bit wider and more elongated. And I hope the same power is enough, but I think it's gonna be enough. Okay. Seems totally different. I don't know, my wire feeder didn't pick up at the beginning. It's basically more likely the liner. I have a shitty liner in there, I guess. But if you look at this, compared to this, this is more tight. Okay, and virtually zero heat affected zone. Theoretically, let's put another one next to it, so I'm not welding two coupons together. I just lay another next to it. Hopefully the wire catches up right away. Goddamn phone. Yeah, I think it's perfect now. I'm gonna check on the phone. Sorry about that design group, but so on the second run my wire feeder caught up. It seems like when I change speed it takes a second or two to correct the speed. I don't know, it's in the memory or something. So that was 2.5 millimeter width, 2.5 millimeter wide, and you see it's kind of full penetration. And this one 3 millimeter wide, and travel speed is 24, laser duty is 100. The wattage, it's depending on your machine, so I cannot tell you, but basically the wobble frequency is 80. Maybe, let's try, I'm not sure it's gonna work. Maybe if we switch to regular single oscillation, maybe it's gonna do the same thing. I don't know, haven't tried it, we're gonna test it right now. No, it doesn't. It's just gonna lay down a perfect smooth weld bead. But it is crazy how smooth it is, gentlemen. I mean, look at it. It's amazing. I know no matter what we're gonna do, it's gonna be just as smooth in these settings. I'm gonna have the rope if I run the Audi. That's what I call it, Audi. What do I run? Infinite sine, but I don't think it's gonna do anything like this. It's gonna be something like this. My wire is not running in the center. I'm probably off a little bit. When you do such a tiny stuff, that could be a problem. So basically, when you want to do such a fine work, you have to do a little bit of pre-work, tune everything, because maybe from this position you see the laser scan, wet the material, and my wire is on the right side, meaning this is not centered. It doesn't matter when I do this or this, but it does matter when I want to do this fine. Let's see if I can not this time. I have to take it apart. And doing the same thing. But basically what happened, my wire diameter is 1.2 millimeter and the bead itself is 1.35. Let's stick with this one, but lower it to 2.5 millimeter. And try to compensate with my hand. Okay. I cheated with my hand. Basically, I turned the laser into the wire. Once again, a beautiful, smooth weld bead. I'm gonna stay in the same setting, and I'm gonna go back to the Audi sign. I'm gonna do a butt weld. I tested this one on the T-joint, it just doesn't work. Okay, let's do this like that. Come on now. Sideways. So once again, I went back to rope welding. Look at that, it's a little bit hot, so I'm gonna wait. I'm gonna do another one. Also lap joint. Like so. Now I'm after perfect, I hope I got it, flat no ridges, that's what I want to do. See? There's the rope. It's fully fused. Maybe the camera doesn't reflect that. There's the other rope. What we're gonna do now, wire this way, good, wire to up, we're gonna go over here, we're gonna go down to 1.5 millimeter. This is not a bubble, so this gun has a bubble, but since it's a 2-galvo system, it draws the geometry, all those presets. I'm gonna show in a second. Now I want to tack weld, but see, in a tiny little spot. Ooh, it's still hot. Damn. Now look at the tiny little tack weld. Okay, what should be done? I know the rope doesn't work over here because that's the Audi sign basically, okay? And just imagine the gun draws these 3 circles, but it draws one at a time. But since there it is. No, not here. It's definitely not here. It's supposed to be here. Advanced parameter. Okay. Maybe it's gonna be here. No. No, it's on the base in the machine. So I cannot show you over here, but I think I have to go all the way back to another settings. I don't want to do that because it's too much hassle. So basically 20,000 millimeter per second is drawing the circles, but one at a time. But since the speed is so insanely fast, what we perceive is 3 circles, but it's 1 circle at a time, just so freaking fast it seems like 3. So what's going on? The center circle is going to be right in the center of this joint, but 1 circle is going to be on this side, the other one this side, and they're going to reflect to each other, right? And it's going to reflect back to my weld bead, and it delivers more energy into the center, so it's just going to melt it up and it's going to be a smooth weld like this. I'm not going to get the rope effect in this configuration. So we can try, but I know because I tested it already. So let me put out some wire. It sucks. Oh, it's too much. Come on. Go back a little bit. Alright. Oh shit. Oh, forget to turn on the wire feeder. Let's try again. So. Fuck, it's hot. See, I don't really have the rope effect as a little bit, but not that much. Let's try one more time on the other side. I'm gonna hold it with the aluminum. And right now I'm running the 3-circle pattern in 1.5 millimeter width. So each circle is half a millimeter wide. Beautiful. Okay. Now, since I blew on all my joints, I don't have any more. I'm just gonna put another one on the top of this one. It could be almost any profile, it doesn't matter. I'm just smoothing out what I did. See, now we are flat. Thin sheet. So as I said, to get to this and to remember everything, I didn't save anything. I remember out of memory. I spent 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, probably 14 coupons, because usually I cut it in pairs. This one is the smallest bead I was able to do, is 1.26 and 1.34, somewhere in this range. I can show you. This is 128. 122. Wow, it's even 117. That's interesting. The freaking wire is 1.2. So the multiplier is approximately 1.05. Normally, if you can achieve 1.4, that's a big task. I mean, not task, big accomplishment. But as I said, this guy, let me return the wire. Okay, I think I can demonstrate it. What do I do? Okay, that's fine. Okay. Let's do this. So 1.5 millimeter. Let's go to 0.2 millimeter. But it's crazy. I don't know if you can see the center of the second spot. And look the other side. It went through from the split second. There's a double circle. Damn, it's hot. double circle. I barely can see it, and I have glasses on. And here is the little spot right there. It's hurry. Usually I use this double circle to do such a thing. The wire is sticking out. The wire is gone. See? Sticking out. Oh, I'm peeking. Not supposed to peek. Forget to shut it up. This one doesn't want to melt away. This one is on this side. Usually. Yep. Here more. There is one way to get rid of it. Next time, when I'm gonna have a little time, I'm gonna try to come up with a modulated setup so I can show you how to close the larger gaps. But don't think about it like a Grand Canyon. So maybe 1/16 or something like that. The way it works, so you set up the wire speed and the laser at the same time intervals. So we push out the wire, shoot it in 100% intensity, so no ramp up time, nothing, 100%. Then X amount of millisecond break, then again wire goes out, automatically it's going to push back your hand and fire again. We want to figure out that particular time frame when your first little tack cool down. That's what you need to look for. And I know not all the machines can do that, but some of them has the future you can do that. I know this one has. So I'm gonna try to work on it. Oh. Okay, it's a good addition to the previous video. Different settings, but 2.5 or 3 millimeters, stuff like that over here. Over here, down to 1 millimeter. 1 millimeter oscillation. I mean, look at this precision. I mean,
That big blob in the center is a failed attempt to close a large gap. I'll have to revisit that later.
Obviously it's gonna be a little bit wider, the weld bead, because my wire by itself 1.2 millimeter. But my beam is only oscillating 1 millimeter, side to side, right? Okay, let's check this. Oops. Ay, ay, ay. Millimeter. Okay. 168. 167. 165. I bet I can reduce it even less. Check this out. Where's my? We're gonna go 26. If I go too fast, then I'm not gonna able to melt my wire, so I can go too fast, but I think I can reduce even. Yes, I did. I reduced it. And we're gonna do another test. It's probably 15-20% reduction. 26. We go 28. How far we can go? Next one, 28. It's still good. The faster we go, the melt pool, it doesn't have time to spread. It's gonna solidify quicker. So look at it. So 28, 26, 28. I'm gonna put one more over here. I'm gonna jump it to 30. I don't know if it's still gonna melt. Because if we go too fast, then the wire is not gonna melt anymore. It's still melting. No matter what, we cannot do less than 1.2 millimeter because that's the wire size. And okay, let's start measuring. God damn it. I mean, something is wrong with this shit. I mean, just by looking at it, you can see compared to this and this is skinnier, and this is 176, 172, 163, 158, 153, 150. 51, 42, 45. So the wire thickness is 1.2. I don't think we can get it any smaller than this, unless I'll put in a thinner wire. But how crazy is that? Okay, and I didn't try. We're gonna go this one. Right, okay. Ooh, it's hot. Regular bubble oscillating. I think it became smaller than this one. $139, $140. I mean, depends how can I grab it. $159, $154, $160. So even less. I'm gonna put one next to this big guy so we can see the difference. Look at the difference. And see the back side. This is the new. Wow. Can I do less wobble? 0.8. Oh. 0.8. Done. So there's still side to side motion. I'm gonna go over here between these two. Look at that. That's called precision welding. So a lot of people chasing 148, 129, depends. The problem is it's so warped and hot, I can't really grab. 148, this one, 159. Okay, I'm gonna go 0.5 wobble length, and I'm gonna go between these two. Look at it. This is the new. It's hot. .137. So the wire diameter is 1.2. That's freaking insane. How precise is that? 126, 136, 130, depends. Yeah, but it's a little bit colder at the beginning actually. Wow. As I said, this is called precision welding. I think the 30 is going to be too fast for this, but I'm going to try it anyway. No, it's not. Oops. 2mm wobble. Okay, and now I'm going to try the Audi. I'm going to try to hold it because Audi is supposed to give me a nice and of course it does. So I haven't changed anything, any settings. Everything is the previous. I only changed the wobble type. So from here to here to here is the regular single axis scan, 1mm. Then I increased it to 2mm by the switch the wobble to the infinite sign, this one, and then the Audi, because the Audi gives me this scale, and I love this scale. I mean, it's beautiful. I don't know where we're gonna use it, but somewhere in some project I'm gonna introduce it to my customers. Just look at it. Oh, I'm too far. I'm gonna do 980 I don't think it's gonna be enough, but we're gonna try it anyway. To do this. That's still good, 980. It's just the spacing is a little bit different. Because of the power. You lower the power, then the spacing is going to change. You increase the power, it's going to be kind of more fluid. Less power is, and with the speed you can increase the distance. And with the width, I'm going to put another one over here. We're going to do 3mm. I think with 3mm it's not going to be enough, but we'll see. 3mm. Oh, it's still good. Still good. As you can see, that's a 3mm. Two. It was 2, also 2. But I lowered the power. This one was 1020, 980, 960. Then I kept the power, but I increased the wobble to 3mm. It's very important, you have to keep the angle, because I just twitched my hand and the angle will screw up over here and over there. So let's do it again. A little twitch. We're gonna go with 2.5. And only thing I'm going to change, regular single axis swing. Everything is the same thing. I don't know if you guys watching closely or not. Do you notice the sound level of this laser? I used to say in my videos, when you weld, not only weld with your eye, so basically the eyesight, what you want to watch for is your angles, the gun geometry, how you're going to hold your gun to the material surface, right? That's, you don't watch, you're not looking at the bottle, you're not supposed to look at the bottle, you want to look at the gun. A lot of people, they have this misconception. And in the same video when I'm explaining this kind of stuff, also use your ear. I don't think anybody has such a system. The laser source is totally different. I'm running on right now 3000 Hertz laser frequency, but I can bump it up to 5000. So when we start, then you can hear the little bzzz noise, then it fades away and almost silent night. Since I told you, just watch it again. over here. Now the aluminum is reflecting, so it's a little bit. When I'm in the 30 range, okay. So the aluminum is not there anymore, the reflection is not going to bother anything. The gas noise basically kills the laser noise. Gentlemen, this one is 2 millimeter or so. Let me show you. Maybe a little bit wider, but around the 2 range. No, actually it's 159, 179, I mean, depending where. But obviously, since the macro lens, it looks much bigger. Look at the other test piece. Oops, my battery in the light died, but still very good. That's my hand twitched, so I accidentally changed the angle over here and over there. In my opinion, the triangle, upside down triangle, is gonna be very good for a lap joint. If you don't move your material, especially then, okay, excellent. I moved my material. Look at that. I set my wobble to 2.5 millimeter. So I'm barely melting away my edges over here. Let's try it. I can't really because it's deformed from so much heat. But I can try the new one. I'm running out of coupons, so yeah, not gonna be too long. Let's test weld. So once again, triangle. We try to keep the 45 because I'm equal wobble length as my material thickness. So when it's equal or larger, you good at 45. When less, then you should drop it to 30. I don't know. I mean, it's amazing, this quality. I wish you guys could touch this. And man, like, it's unbelievable. Let's run the other side. I'm gonna do 2.2. I'm gonna lower my wobble. 2.2. I'm gonna try to hold it with this guy. Everything is the same. 960 watts. I think I would be okay with less, but now look at that. Let me try to zoom in. Oops, that's too much zoom. I don't know how much field of depth you can see on the camera, and the shadows are kind of working against me, but it's so smooth. Unbelievable. Look at the heat affected zone. It's non-existent, literally non-existent. And we have the penetration what we wanted. I'm not kidding, I'm blown away. I'm testing. I have a couple of more coupons. We're gonna do, it's still hot. Now this is hot. I'm down to 3. Yeah, shouldn't move the motor there, but look at it. I moved it over here, but right after, look at it. If you do some stainless steel NSF work and you produce such a weld, you don't want to clean it, you want to show up. I mean, it's you want to show up. Look at it. When my machine can be, now I'm going to switch to the circle, single circle. And my problem was before it was hot, so I had to move my hand. I haven't tried the circle on this joint configuration yet, so this is the first time. As I said, I'm trying to figure out something that's fishy over there at the very end. And once again, it's just unbelievable. Look at it. I tipped my hand or something on the very end. That's why you want to have your material clamped down and stuff like that, so nothing like this is going to happen. But as I said, I'm testing. I'm gonna do one more. It's cooled down already. Same settings over here. Let me see if I get the clamp. Gentlemen, this unit can do this all the way up to 1/4 inch, no problem. Steel, stainless steel, aluminum, everything. Look at it. I don't have a leftover fresh material. This is just unbelievable. quality. I don't even know how to explain it. I'm gonna try over here inside this type over here. I don't know if it's gonna work out. Okay, I can get in. Let me go back to the settings. So I have to bump it up to 1020 at least. Then over here 24. Over here 80. And have to choose this. And let's see. Yeah, this is the. I'm gonna go back to 22 because I'm not sure this idea is going to work in this joint configuration. Or what's gonna be the end. It's definitely not the same deal. But we just got a very nice smooth edges, but we have a little bit of scaling, not as extensive as over here. That's because of the reflection. So this is what we're running. Let me unhook it. This is what we're running. Let me shut this off. Okay, so this setup gives me this nice scaling effect. But when we are in a stainless steel, which is highly reflective, one of the highest, not as high as the brass or bronze, but very high. So we lay down 3 circles, and the one from here bouncing over here, and the one goes over here bouncing down here, so it's kind of smooth my weld bead out. So no, very minimal effect visible compared to this, because nothing to bounce it over here. I mean, not like we needed to, but you see the scaling compared to, it's smooth as a baby's butt. My firstborn son. All of them. So over there we see a little scaling. I'm kind of after what we see over here, which I kind of dialed in. From now on I can set it up to any thickness, because this stupid machine has way too many things to push. You go setups, look, then you go advanced parameters, you have to punch in a whatchamacallit, password, but then this doesn't really matter for us right now. Over here a couple of more parameters and you could save it. So save the process library. I didn't save it yet. Okay, let's do spot welding. So, okay. Here we go. 5, maybe. we do 5, then it's visible. I don't know if any of you see similar gun for sure. Somebody, I know in effect one gentleman is watching sometimes my. Here, let's do this. Okay, see? Then this one. I don't know if yeah, it's gonna go, right? Okay. Then just a single circle. Okay. And hourglass. Okay. Then you got the double circle. I mean, that's the single triangle, upside down triangle, and this would be, I call it Audi, but it's not exactly missing one ring. Let me see. It's quite tight, the Audi. I mean, also you have to know that this gun has a 20 micron beam. IPG has a 60 micron beam. So look, if I close up, look at that. Now that's 3 triangles right next to each other and 3.5 millimeter width. Okay? So that's freaking crazy. Alright. The IPG, I cannot do such a small with the regular bubble. Let's go down to 1. How about that? How crazy is that? Look. Okay, look this. There. I'm gonna aim in the center. See? Let's go 0.1. I could stop it. I mean, I can put it right below. See, I was able to put it below. Okay, how about I put it over here? Yeah, if my hand wouldn't move. And it's a circle. The size is depending on how far and how I was moving my hand. It came closer and closer and closer, so the size is start to shrink and go farther. The size is gonna, see, it's getting bigger. We go extremely close. See, so tiny. We go 5. We go 5, and we're gonna shoot it over here. nuts. A lot of guns are out there with the dual galvo system. So we got one galvo over here, one over here, but they are older. This is 25 model. There's a couple of more variable, and if you guys did see my cleaning video, it has 11 different cleaning patterns, 7 welding patterns, but the 7 welding patterns you can use it for bead cleaning. Okay. I never cut with this gun. Maybe next time we're gonna cut, but I don't really care about cutting, because if I cut, I use my big laser. Once again, if you're familiar with my channel, look, with 200 watts. We did this with 200 watts. You see? And the standoff was so far and almost penetrated. I mean, this one, okay, that wasn't 100% penetrated. Actually, it's a little blown through. This one too. This one just reached the surface on the other side, same thing. Barely reached the surface on the other side. It very well reached the surface on the other side. And if you look closely, I don't know, I hope you can see it, the bunch of little dots. And I was aiming from here, something like this, right? And on 200 watt settings. It's stupid, crazy. So, what's the lesson out of this little demonstration, gentlemen? The smaller is your wobble length, the more energy you deliver into your material. So if you need to achieve a deep penetration, you want to shrink your wobble width as much as you can. And you need a perfect edge. Because if you have perfect edge, then you can shrink it to, let's say, 1 millimeter, or depending on the software what your manufacturer has, maybe even less. I could do 0 if I want to. 0. I can run 0. But whichever welding apparatus has a cutting option, you can go to all the way to 0 for sure. Whichever doesn't have, maybe you cannot. Maybe there's a minimum wobble in there. I'm not sure, because I have only the IPG, 2 different IPGs. I mean, it's the same, just one of them is a little bit newer inside than the other one. One of them is 100% legacy, the other one inside is the XR, but outside is the legacy. And most of the time I'm using the XR for almost everything. But now not anymore, because I'm gonna use this boy for stainless steel and such. And once I finish with the brass project, hopefully by the weekend I'm gonna be done, then I'm gonna go back to aluminum on the IPG. And why I'm doing this? Because on this new system I still need a hands-on time. I only have like 40-50 hours laser time on this gun. That's not enough. When we weld aluminum, 1/4 inch, 3/8 and stuff like that, long freaking welds, 3 feet, 4 feet continuous, both sides. Can make a mistake. So since I'm not perfecting this gun and these settings, I'm working on the stainless steel for now. Once I'm done, then I'm gonna play with the aluminum. I tested already, so it's welds aluminum, no problem, it welds anything. But we want better, I mean, just look at this test pieces. Over here I was trying to close gap. Here, I was trying to close gap, and if the material starts to warp, you cannot do that, so I have to clamp it down. Or I have to go slower. I was able to. Let me point out. I think it's gonna work pretty much similar way when you do it for MIG or TIG. I don't know if you see this from here to here. I perfectly covered 1/16 of gap. Now what I figured out, this tube is not so good when I wanna do, so I have to come up with my own tube settings. I already have the idea. I'm gonna mimic what we have on the IPG. On the IPG I have one single nozzle, nothing else. I don't need anything else. It's good for everything. So if I can master one nozzle, obviously I have to custom make it, then I'm not gonna have any problems, because the tracking was the problem. Warpage and tracking. I used the figure 8, slow speed, and look, from here to here I was perfect. Then I ran off track because the warpage and the nozzle. Then I was trying to put another one, I mean totally fucked up. I lowered the energy, that's why we have these bumps. Over here we got perfect energy, but I was kind of holding with the IPG. What I'm doing when I close gaps, I kind of force hold the gun so the wire keep feeding and fills the gap. I mastered that on the IPG, but that one is a side bubble. So I mean, I have 5 years of gun time on that one. This one is a little bit different. Every setting is different, and I'm not interested to run the straight wobble. The reason I purchased this, because I'm looking for this kind of stuff, this decorative for my customers. See? This kind of stuff.